December 7th, 1941. The day after Pearl Harbor, a telegram arrived at the Chrysler Corporation headquarters in Highland Park, Michigan. The message was terse, urgent, and would trigger one of the most remarkable industrial transformations in human history. Within 6 months, factories that had never built anything more dangerous than a sedan would be producing tanks that would help crush the Axis powers. What seemed impossible, converting America's automotive empire into an arsenal of democracy, would become not just possible, but devastatingly effective. The story of how Detroit went from making cars to tanks is not merely about industrial conversion. It is about the collision between American ingenuity and existential necessity, about men who had spent their careers perfecting chrome bumpers suddenly designing armor plate, about assembly lines that had revolutionized consumer goods being weaponized against fascism. This transformation would prove to military, planners, to enemies, and to allies alike that American industrial capacity represented a force more powerful than any army. January 1942. K.T. Keller, president of Chrysler Corporation, stood in what had been an empty field in Warren Township, Michigan, just outside Detroit. Around him, construction crews were already breaking ground on what would become the Detroit tank arsenal. The field was empty. The blueprints were theoretical. The machinery had not been ordered. The workers had not been hired. Yet Keller had promised the United States government that this facility would be producing tanks within 6 months. Not prototype tanks, not experimental models. Combat-ready M3 medium tanks that would face German panzers in North Africa. His engineers thought he was insane. His board of directors questioned his judgment. Military officials were skeptical but desperate. America had entered the war with an army ranked 18th in the world, equipped with obsolete tanks that were no match for German armor. The nation needed modern tanks immediately, and it needed them in quantities that seemed fantastical. Keller's promise was not based on existing capability. Chrysler had never built a tank. The company had never manufactured armor plate. Its engineers had no experience with military specifications. Its workers had spent careers building cars, not weapons. Yet Keller understood something that would prove decisive in the industrial war America was about to fight. The skills, machinery, and organizational methods that had made Detroit the automotive capital of the world were precisely what was needed to mass-produce tanks. The challenge was not whether it could be done, but how quickly. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The path to this moment had begun not in December 1941, but years earlier, when the Roosevelt administration first recognized that war was inevitable and America's industrial capacity would determine the outcome. In May 1940, as France collapsed under German assault and Britain stood alone, President Franklin Roosevelt delivered a speech to Congress that shocked the nation. He called for the production of 50,000 aircraft annually, a figure that represented more than 15 times America's current production capacity. The announcement was met with disbelief, both at home and abroad. Critics called it political fantasy. Skeptics pointed to the obvious impossibility of such expansion. Germany, which had been preparing for war since 1933, produced fewer aircraft than Roosevelt was demanding. How could America, with its tiny military and consumer-focused industry, possibly achieve such production? Yet Roosevelt understood what his critics did not. The Great Depression had left America with enormous unused industrial capacity. Factories sat idle or underutilized. Millions of skilled workers were unemployed or underemployed. Machine tools that could produce components for automobiles or refrigerators sat unused. What appeared to be economic weakness was actually strategic advantage. America did not need to build industrial capacity from nothing. It needed only to redirect existing capacity from civilian to military production. The infrastructure for industrial mobilization already existed, requiring conversion rather than creation. Detroit represented the heart of this unused capacity. In 1941, the American automotive industry produced more than 3 million passenger cars annually. The factories that built these vehicles were the most advanced manufacturing facilities in the world, employing assembly line techniques pioneered by Henry Ford and refined by General Motors, Chrysler, and smaller manufacturers. These facilities contained machinery capable of precision metalworking, stamping, welding, and assembly. They employed workers skilled in operating this machinery efficiently. They embodied organizational methods that had revolutionized manufacturing by breaking complex products into standardized components that could be mass-produced and assembled. When Roosevelt called for massive military production, he was asking Detroit to apply its existing expertise to different products. The fundamental challenge was not building new industrial capacity, but converting existing capacity fast enough to matter. The automotive industry understood mass production better than any other sector of American economy. A tank, complex as it might seem, was mechanically simpler than an automobile in many respects. It had fewer moving parts, required less precision in many components, and could be built using techniques already familiar to automotive engineers. The challenge was adapting automotive production methods to military specifications, training workers in new procedures, and doing so at a pace that would allow American tanks to reach battlefields before the war was lost. The first major conversion came at General Motors, which had been quietly working on military contracts even before Pearl Harbor. In April 1941, GM's Cadillac division received a contract to produce M5 light tanks. The company's engineers studied the tank design, analyzed the components, and concluded that automotive manufacturing techniques could be adapted effectively. The M5 was relatively simple by tank standards, a light reconnaissance vehicle weighing approximately 15 tons, armed with a 37mm gun and machine guns. Cadillac engineers broke down the tank into subsystems, assigned each subsystem to different production teams, and applied assembly line methods to tank manufacturing. By August 1941, 4 months before Pearl Harbor, Cadillac delivered its first production M5 tank. The military was impressed but skeptical. One tank proved nothing. Could Cadillac produce them in quantity? Could the quality be maintained? Could production scale up to meet military requirements? The answers came quickly. By December 1941, Cadillac was producing 24 M5 tanks per day. The facility had been converted from luxury automobile production to tank manufacturing in months, not years. Workers who had been installing leather seats and chrome trim were now welding armor plate and mounting weapons. The machinery that had produced engine blocks for Cadillac sedans was now producing tank transmissions. The same organizational methods that had made Cadillac automobiles symbols of American luxury were now producing weapons of war with brutal efficiency. But the M5 light tank, while useful, was not sufficient. America needed medium tanks that could face German panzers in direct combat. The M3 medium tank, later supplemented by the superior M4 Sherman, represented the backbone of American armored forces. These vehicles were far more complex than light tanks, weighing 30 tons, armed with 75mm guns, requiring sophisticated transmissions, complex suspension systems, and thick armor plate. The military needed thousands of these tanks, and they needed them immediately. In June 1941, the War Department approached Chrysler Corporation about producing M3 tanks. Chrysler had no experience with military production. The company built cars, not weapons. K.T. Keller, Chrysler's president, was a production engineer by training. a man who understood manufacturing at a fundamental level. He toured the Army's Rock Island arsenal, where tanks were being built using traditional methods by skilled craftsmen. What he saw convinced him that automotive mass production techniques could revolutionize tank manufacturing. Rock Island Arsenal was producing approximately 5 tanks per month, using methods that would have been familiar to 19th-century armourers. Each tank was essentially custom-built by teams of skilled workers who fitted components together individually. Quality was high, but quantity was pathetically inadequate. Keller immediately understood that these methods could never produce the thousands of tanks America would need. He proposed building a dedicated tank production facility using automotive assembly line methods. The War Department was skeptical but desperate. They awarded Chrysler a contract to design and build what would become the Detroit Tank Arsenal. The challenge Keller faced was staggering in scope and compressed in timeline. He needed to design a factory optimized for tank production using assembly line methods never before applied to military vehicles. He needed to order machinery, much of which would need to be custom designed and built. He needed to hire and train thousands of workers, most of whom had never seen a tank, let alone built one. He needed to establish supply chains for components, including armor plate, that American steel mills had limited experience producing. He needed to do all of this while tanks were desperately needed on battlefields halfway around the world. Traditional industrial facility construction took years. Keller had months. He assembled a team of Chrysler's best production engineers and gave them an impossible mandate: design the most efficient tank production facility imaginable and build it in 6 months. The engineers worked around the clock, designing the facility while construction crews simultaneously broke ground. Blueprints were delivered to construction teams in sections. As they were completed, machinery was ordered before final facility designs were finished, based on projections of what would be needed. Workers were recruited and began training even before the factory building was enclosed. Every traditional sequence of industrial construction was compressed, parallelized, or eliminated entirely. The result was organized chaos that somehow coalesced into 23 functioning reality. The Detroit Tank Arsenal site in Warren Township was chosen for its proximity to Detroit's industrial infrastructure, railroad connections, and available labor force. In January 1942, it was an empty field. By March, the main building structure was rising, a massive facility covering 40 acres under one roof. By April, machinery was being installed in sections of the building even as construction continued in other sections. By May, the first workers were beginning actual production operations while construction crews still worked overhead. By June, the facility produced its first M3 medium tank, exactly 6 months after ground was broken. The achievement seemed impossible, because by all traditional measures, it was impossible. Industrial facilities simply did not go from empty field to producing complex military equipment in 6 months. Yet the Detroit Tank Arsenal had done precisely that, by abandoning every traditional assumption about industrial construction and operation. The key was applying automotive production philosophy to every aspect of the operation. In traditional tank production, skilled craftsmen built tanks one at a time, fitting components together individually. Automotive production broke vehicles into standardized sub-assemblies produced separately, then brought together for final assembly. The Detroit Tank Arsenal applied this philosophy systematically. Tank hulls were produced on one assembly line, turrets on another, engines and transmissions on separate lines. Suspension systems, track assemblies, weapons mounts, all produced separately using specialized machinery operated by workers trained in specific tasks rather than general craftsmanship. The machinery itself represented innovation driven by necessity. Much of the equipment used at Detroit Tank Arsenal did not exist when the project began. Machine tools had to be designed and built specifically for tank production operations. Welding equipment needed to handle armor plate thickness that automotive welding never encountered. Lifting equipment needed to move 30-ton vehicles through assembly processes. Heat treating facilities needed to process armor components. Every piece of equipment was custom designed, ordered from machine tool manufacturers operating at maximum capacity, installed in a facility still under construction, and debugged during production operations. The workers who operated this machinery came overwhelmingly from automotive industry backgrounds. They understood assembly line work, specialized task performance, quality control procedures, and production quotas. What they did not understand was tanks. Chrysler established intensive training programs that took automotive workers and converted them into tank builders in weeks. The training focused not on comprehensive understanding of tank design or military doctrine, but on specific tasks each worker would perform. A worker installing suspension. Components needed to understand suspension installation procedures, not overall tank design. A welder joining armor plates needed to understand armor welding techniques, not military tactics. This specialization allowed rapid training and high efficiency, but required careful coordination. The supply chain challenges were immense and unprecedented. A single M3 medium tank contained approximately 18,000 individual parts. Many of these parts were standard automotive components that existing suppliers could provide, items like spark plugs, wiring, gauges, rubber hoses, but many components were unique to tank production, items that no supplier had ever manufactured. Armor plate represented the most critical and challenging supply requirement. American steel mills in 1941 had limited experience producing armor-quality steel. The metallurgy was different from structural steel. The rolling processes were different. The heat treatment was different. The quality control was more stringent. Initial armor plate deliveries were often rejected for quality defects, creating production bottlenecks as the Detroit Tank Arsenal waited for acceptable material. Chrysler worked directly with steel suppliers to improve armor production, sending engineers to steel mills to help develop proper procedures, sharing quality control data, even helping finance equipment purchases needed for armor production. This direct collaboration between manufacturer and suppliers was unusual in traditional industrial practice, but became standard in wartime production. The alternative was delay, and delay meant soldiers dying with inadequate equipment. The relationship between Chrysler and the military also required adjustment on both sides. Military procurement traditionally involved detailed specifications, competitive bidding, extensive testing, and slow approval processes designed to ensure quality and prevent waste. These procedures made sense for small-scale procurement over extended timelines. They were catastrophically inappropriate for emergency wartime production, requiring thousands of tanks immediately. Chrysler engineers frequently found military specifications impractical or impossible to meet using mass production methods. They proposed changes that would allow higher production volumes but deviated from standard specifications. Military procurement officers, trained to enforce specifications rigidly, initially resisted these changes. The breakthrough came when both sides recognized that perfect was the enemy of good enough. A tank that deviated slightly from ideal specifications but could be produced in quantity immediately was infinitely more valuable than a perfect tank that would not exist for months. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By September 1942, 9 months after Pearl Harbor and 3 months after producing its first tank, the Detroit Tank Arsenal reached production of 100 M3 tanks per month. This represented more tank production than the entire American industry had achieved in all of 1941. Yet, it was still inadequate. The military needed thousands of tanks. Chrysler needed to increase production dramatically. Keller and his engineers analyzed the production process systematically, identifying bottlenecks and constraints. Armor plate supply remained the limiting factor. Chrysler worked with steel suppliers to increase armor production capacity, even financing expansion of supplier facilities. Workforce size needed to increase, requiring additional recruiting and training. Machinery utilization needed to improve through better scheduling and maintenance. Supply chain coordination needed refinement to prevent parts shortages from stopping assembly lines. Each improvement was incremental, but cumulatively they drove production upward, steadily. By December 1942, 1 year after the project began, Detroit Tank Arsenal was producing 200 tanks per month. By June 1943, production reached 400 tanks monthly. At peak production in December 1943, the facility produced 896 tanks in a single month, more than all Axis powers combined produced during the same period. The transformation from empty field to peak production had taken exactly 2 years. Traditional industrial development timelines suggested such a project should require 5 to 7 years. Chrysler had compressed the entire process into 2 years by abandoning traditional sequential development in favor of parallel processes, accepting imperfect solutions that could be implemented immediately, rather than perfect solutions that would take longer, and maintaining absolute focus on the singular objective of producing tanks in quantity. The production numbers told a story of industrial capacity that seemed impossible. The Detroit Tank Arsenal alone produced more medium tanks than the entire German tank industry produced during the entire war. One facility, built from nothing, using workers with no tank-building experience, outproduced the tank industries of Germany, Italy, and Japan combined. This was not because American tanks were simpler or inferior. The M4 Sherman tank that replaced the M3 was mechanically sophisticated, well-armored for its class, reliable, and combat effective. It was because automotive production methods, when applied to military manufacturing, achieved production volumes that traditional military manufacturing could never approach. The tanks rolling off Detroit's assembly lines in 1943 represented more than industrial achievement. They represented a fundamental transformation in how wars would be fought and won. But the human dimension of this transformation was complex, often uncomfortable, and spoke to costs that production statistics could never capture. The workers who built these tanks were not soldiers. They were men and women who had spent the 1930s struggling through economic depression, grateful for any employment, accustomed to building products designed to make life easier and more comfortable. Now they were building machines designed to kill other human beings, and this psychological shift was neither simple nor painless. Martha Griffiths worked as a welder at the Detroit Tank Arsenal from 1942 until the war's end. Before the war, she had never held a job outside her home. She was a housewife and mother whose husband worked at Ford's River Rouge plant. When the Arsenal began recruiting workers, she applied partly from patriotic duty, partly from economic necessity, partly from curiosity about capabilities she had never been permitted to explore. Her training lasted 3 weeks, intensive instruction in welding techniques specific to armor plate. The work was physically demanding, mentally exhausting, and deeply meaningful. Years later, she would recall the strange cognitive dissonance of her experience. She took pride in her welding quality, in producing clean seams that met stringent specifications, in contributing to production quotas that factory management posted prominently. Yet she understood that her work product was armor that would be hit by German shells, that the quality of her welds might determine whether the young men inside survived. She never met any tank crews. She never saw combat. But she carried throughout her life the knowledge that her hands had built machines in which American soldiers fought and sometimes died. This was the hidden cost of industrial mobilization that production statistics never captured. The speed of Detroit's conversion created quality challenges that engineers worked frantically to address. Early tanks produced at the Detroit Tank Arsenal experienced mechanical failures at rates higher than acceptable. Transmissions failed, engines overheated, electrical systems malfunctioned. These were not surprising problems for a facility ramping up production of unfamiliar equipment using untrained workers operating new machinery. But each failure represented potential catastrophe for tank crews in combat. Chrysler established quality control procedures more rigorous than those used in automotive production, inspecting components at multiple stages, testing completed vehicles extensively, tracking failure patterns to identify systematic problems. The company assigned engineers to follow tanks into combat theaters, gathering data on field performance, identifying problems that testing had not revealed, feeding information back to production teams. This feedback loop was unprecedented in military procurement. Traditionally, manufacturers delivered equipment and moved on to the next contract. Chrysler treated tank production as an ongoing engineering challenge, requiring continuous improvement. The result was that later tanks were substantially more reliable than early production models, incorporating hundreds of small improvements identified through field experience. But those early tanks, the ones with higher failure rates, had already been shipped to combat. They fought in North Africa, Sicily, Italy, with crews who learned to work around mechanical problems, who developed field repair procedures, who sometimes died when equipment failed at critical moments. The human cost of learning curve production was real and could never be fully calculated. The M4 Sherman tank that became the primary American medium tank from 1943 onward represented Detroit's production philosophy, applied to military equipment with both brilliant success and troubling limitations. The Sherman was designed explicitly for mass production. Its components were standardized. Its armor was welded rather than cast in many versions, allowing faster production. Its engine was derived from automotive components, using proven technology rather than developing new systems. Its transmission was straightforward and reliable. Its weapon systems were adequate rather than exceptional. Every design choice prioritized production volume and mechanical reliability over maximum combat capability. The result was a tank that German Panthers and Tigers could defeat in direct combat. The Sherman's armor was thinner. Its gun was less powerful. Its survivability was lower. German tank crews who faced Shermans in battle often had technical advantages. Yet the Sherman won the war because Detroit could build 15 Shermans for every Panther Germany produced. The mathematical reality of industrial production trumped tactical superiority. This truth was simultaneously America's greatest strategic advantage and a source of deep moral discomfort. American tankers went into combat knowing their equipment was inferior to what they might face. They understood that survival often depended on numerical superiority rather than technical excellence. They fought and died in machines that represented calculated trade-offs between production volume and combat effectiveness. The tank commanders who led Sherman crews into battle against German armor understood these trade-offs intellectually but experienced them viscerally. Lieutenant Clarence Smoyer, who commanded a Sherman in the 3rd Armored Division, described engagements where his crew relied on coordinated attacks by multiple Shermans to defeat single German tanks. The tactics were effective. They achieved objectives. but they required accepting casualties that better equipment might have prevented. This was the hidden cost of industrial production philosophy applied to military equipment. The workers at Detroit Tank Arsenal never stopped being aware of this reality. They read newspaper accounts of tank battles. They followed combat reports. They understood that the machines they built were being destroyed in combat, that American soldiers were dying inside vehicles these workers had assembled. Management tried to frame production as purely patriotic contribution, emphasizing that every tank built helped shorten the war and save American lives. This was true, but it was incomplete truth. The tanks also carried young men into combat where some died, and the workers who built those tanks carried that knowledge. The psychological weight of this reality was rarely discussed publicly during the war. Patriotic duty demanded cheerful dedication to production. Propaganda emphasized positive contributions while minimizing costs. Workers were celebrated as home front heroes contributing to victory. This framing was necessary for morale and production, but it obscured complex emotional realities. Years after the war, when historians interviewed Arsenal workers, many described lasting psychological effects. They had participated in industrial killing at scale, building machines designed for combat, knowing their work product would be destroyed, and the men inside potentially killed. This knowledge could not be easily reconciled with the satisfactions of craftsmanship, the pride of accomplishment, the camaraderie of shared purpose that also characterized their experience. The impact of Detroit's tank production extended far beyond American forces. Through Lend-Lease programs, American tanks equipped British, Soviet, and other Allied forces worldwide. The Soviet Union alone received more than 4,000 American medium tanks, supplementing Soviet production and helping sustain offensives that drove German forces back toward Berlin. British forces used American tanks extensively in North Africa and Europe, particularly the Sherman, which became the backbone of British armoured divisions. Free French, Polish, and other Allied forces equipped themselves with American production. The global reach of Detroit's output demonstrated industrial capacity translated into geopolitical power. Nations that could not produce tanks in quantity became dependent on American supply. This dependency shaped post-war relationships and established patterns of military equipment supply that persisted for decades. The Detroit Tank Arsenal was not unique, but rather emblematic of broader transformation across American industry. Ford operated a tank production facility at its Highland Park plant. General Motors produced tanks at facilities in Detroit and Grand Rapids. Chrysler later opened a second tank arsenal in Delaware. Smaller manufacturers produced specialized armored vehicles, tank destroyers, and support equipment. The combined output of American tank production reached 37,198 vehicles in 1943 alone, the peak year of American tank production. This single year's output exceeded total Axis tank production during the entire war. The scale of production was so overwhelming that it created surplus capacity. Some tanks were built and immediately placed in storage, never seeing combat. Others were produced, shipped overseas, used briefly, and then scrapped when better models became available. The industrial abundance seemed wasteful by any peacetime standard, but represented strategic insurance. America built tanks faster than they could be destroyed, ensuring that numerical superiority would never be in question. The transformation of Detroit revealed uncomfortable truths about industrial civilization and modern warfare. The same technological sophistication and organizational methods that produced prosperity in peacetime could be weaponized with devastating effectiveness. The assembly line techniques that put automobiles within reach of ordinary Americans also produced tanks in quantities that enemies could not match. The machine tool industry that enabled American industrial leadership also enabled rapid conversion to military production. The engineering expertise that made American factories the most efficient in the world also optimized killing capacity. This was not moral equivalence between civilian and military production, but recognition that the boundary between them was far more permeable than comfortable to acknowledge. The engineers who designed tank production systems were the same engineers who had designed automobile production systems. The workers who built tanks had built cars. The factories that produced weapons had produced consumer goods. The conversion happened rapidly because the underlying capabilities were identical, requiring only redirection rather than creation. This reality suggested that any advanced industrial society possessed latent military capacity that could be activated quickly if circumstances demanded. The implications were sobering for anyone contemplating future conflicts between industrial powers. The end of tank production at Detroit facilities came as abruptly as its beginning. In May 1945, Germany surrendered. Tank production was immediately curtailed as the military cancelled contracts and redirected resources toward the Pacific Theater. By August 1945, Japan surrendered following atomic bombings. Within weeks, tank production ceased entirely. The Detroit tank arsenal began shutting down production lines. Workers received termination notices. Machinery fell silent. The facility that had produced tanks continuously for 3 years stopped as suddenly as it had started. The workers who had spent years building tanks returned to civilian life carrying experiences they rarely discussed. Martha Griffiths returned to her home and raised her children, seldom speaking of her time at the arsenal except to mention it factually when asked about wartime work. Thousands of others followed similar patterns, treating their contribution as simply what was required during extraordinary times, not requiring extensive reflection or public recognition. The psychological impact remained private, personal, sometimes painful. These workers had participated in industrial warfare at unprecedented scale. They had been part of victory but also part of killing. Both truths coexisted uncomfortably. The Detroit tank arsenal itself sat largely unused after the war until the Korean conflict brought renewed demand for military equipment. It operated sporadically during Cold War decades, producing tanks during military build-ups and sitting idle during peace. The facility finally closed permanently in 1996, demolished in 2000, leaving only historical markers indicating what had stood there. The site where America demonstrated industrial capacity could defeat military excellence became a commercial development, the transformation from weapons production to civilian use, completing a cycle that had begun in reverse 6 decades earlier. The lessons from Detroit's transformation remained relevant long after the factories closed. Industrial capacity determines outcomes in total war between modern nations. Production volume matters more than technical excellence when fighting wars of attrition. Mass production techniques can be applied to military equipment with devastating effectiveness. These principles, proven definitively in World War II, shaped military planning for subsequent conflicts and influenced defense industrial policy for generations. Yet the human dimensions of these lessons remained uncomfortable. Workers who built tanks were not warriors, but participated in warfare. Engineers who optimized production were not soldiers, but contributed to combat effectiveness. Factory managers who met production quotas were not commanders, but influenced battle outcomes. The entire home front population participated in industrial warfare, whether they acknowledged it or not. This collective participation in military effort at scale was unprecedented in human history and created psychological and moral complexities that peacetime production never involved. The story of how Detroit went from making cars to tanks in 6 months is ultimately a story about capability and cost, about what industrial societies can achieve when necessity demands and what that achievement requires. The capability was demonstrated beyond question. America converted consumer goods production to military production faster than anyone thought possible, built facilities from nothing, trained workers with no relevant experience, produced weapons in quantities that overwhelmed enemies. This achievement helped win the war, shortened the conflict, saved countless lives that would have been lost in prolonged fighting. These were real and significant contributions deserving recognition. But the cost was also real, even when less visible. Workers carried psychological burdens from participation in killing at industrial scale. Soldiers fought with equipment representing calculated trade-offs between production volume and combat effectiveness. The same industrial sophistication that created prosperity also optimized warfare. The boundary between civilian production and military capacity proved far more permeable than comfortable to acknowledge. Both capability and cost were real, neither negating the other, both requiring recognition for complete understanding. The tanks that rolled off Detroit assembly lines helped defeat fascism, liberate Europe, and establish American industrial dominance in the post-war world. They were also machines in which young men died, built by workers who carried that knowledge privately, representing industrial warfare's capacity to transform entire societies in pursuit of military victory. The transformation was neither simple nor uncomplicated, neither wholly admirable nor entirely troubling. It was profoundly human in its mixture of achievement and cost, capability and consequence, triumph and tragedy. The same hands that had built automobiles to improve civilian life built tanks to take military lives. The same factories that had represented prosperity became instruments of warfare. The same industrial methods that had raised living standards were weaponized with devastating effectiveness. This was the reality of total war in industrial age, uncomfortable in its implications, but undeniable in its historical truth. 8 decades later, the lesson remains clear and sobering. Industrial capacity represents latent military power that can be activated rapidly when circumstances demand. The conversion from civilian to military production can happen in months rather than years. Mass production techniques can be applied to weapons as effectively as to consumer goods. These capabilities exist within every advanced industrial society, waiting to be activated by necessity or choice. The workers who demonstrated this reality at Detroit's tank arsenal are nearly all gone now, their experiences passing from living memory into history. But the transformation they accomplished, the capabilities they revealed, and the costs they carried remain relevant for understanding how industrial societies wage war and what that warfare demands from ordinary people, transformed into participants in industrial killing. Their story is one of remarkable achievement achieved at real cost, of capability demonstrated through sacrifice, of transformation that was neither simple nor uncomplicated, but profoundly consequential for the world they helped reshape. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.